Okay, we're still continuing with the basic theorems of probability, and we're going to do another example. So they say assume that a magnetic tape, or this is an old book, so for a digital computer is classified as defective if it has either of the following imperfections. 1, the magnetic coating is improperly applied, or 2, the tape has a fold or a tear. Otherwise, it is classified as defective. So there's 2 ways that it can be defective. Otherwise, it's not defective. So a survey of defective reels returned to the manufacturer shows that 0.5% of all reels produced have improperly applied coating. So there's a 0.5% chance of one type of defective product, and a 0.3% of all the reels have tape folds or tears, so that's a second type, and 1% have both imperfections. Okay, so what they mean is they just have this one, or they just have this one, or they have both. Find the probability that a purchaser will receive a defective item. Okay, so let E be the event that you have the first type of defective product, and F be the event that you have the second type of defective product. And so the probability of E is 0.005, that's 0.5%. Probability of F is 0.003, and the probability of E intersect F, we were told, is 0.001. The event that the purchased reel is defective is if you get either E or F or both. And the probability of this event is this plus this minus that. So it's 0.007. In other words, 0.7% of all reels produced are defective. So here they remind us that if you're trying to compute P of E union F, one way, if you have the set of sample points, and if you know the probability of each individual sample point, you can calculate P of E union F by summing up the probabilities of each of the sample points individually, like this. In general, if E and F are mutually exclusive and you know the probability of E and the probability of F, then you can do it like this. And in general, if you know the probability of E, the probability of F, and the probability of E and F, you can do it like this. Okay, one more theorem. This is theorem 3, and this has to do with calculating the probability of the complement of E. So if E is an event in a finite sample space, so again we're limiting our discussion to finite sample spaces, then the probability of E prime, that is the probability of the complement of E, is 1 minus the probability of E. So this is obvious when you think about it. For example, here in example 3 we just showed that the probability of a purchaser receiving a defective reel is 0.007. So what's the probability that they receive a non-defective reel? So it's obviously 1 minus 0.007, right? So that's what this says. The probability, so E would be defective, then non-defective would be E prime. And what's the probability of E prime? It's 1 minus the probability of E. Okay, but if you want to prove it mathematically, we can observe that E union E prime is all of S. Right? And also, E and E prime are disjoint. Their intersection is the empty set. Right? They don't have obviously they don't have anything in common. So what can we do? We can say the probability of E plus the probability of E prime equals the probability of S. Why? Because we can change plus union to plus as long as these two events are mutually exclusive or disjoint sets. So we get the probability of S is, we know, is 1, and that's equal to this. So that's what they write. 1 equals the probability of S equals this, probability of this, but we can split this up because they're disjoint. So we get 1 equals this plus that, which we can rewrite as probability of E prime equals 1 minus probability of E.